Hello and welcome back to hansonmath.com tutorial videos. Today's video regards the unit circle. Specifically, where do the coordinate values come from and what does this all mean? How do you use it? This lesson would be targeted at Algebra 2 students, trigonometry students, and high school pre-calculus students. So here we go. By definition, the unit circle is a circle centered at the origin with radius of length 1. That's where the unit name comes in, 1 unit. So from the origin to the boundary of the circle, point on the circle, that radius is worth 1. If I go this way, that length is worth 1. You know, it doesn't matter which way you go, the length is worth 1. But where you end up on the circle, you'll have a given coordinate. So for example, the coordinate of this point right here would be 1, 0, because the whole radius is length 1, and I did not move off of the x-axis, so my y-coordinate is 0. This point here would be, you know, if you just did an approximation, it would be somewhere past 7/10, not quite 8/10, and then up to, you know, somewhere between 0.6 and 0.7. So its coordinates would be approximately 0.75, comma, you know, maybe 0.68, something like that. But the point of this is to not have approximations, it's to get exact values. So that will be today's lesson. Now, what about degree measures going around this unit circle? Well, let's take a quick look at that. If you are at the start of the circle here and you have not traversed around the circle, you are at 0 degrees, which means you haven't done any rotation. If you go a quarter of the way around, so if you go from here to here, you've gone a quarter or 90 degrees around the circle. From here to here, you went halfway around, which is 180. Another quarter turn is 270, which is 90 times 3. And then back to the start, that's a 360 or 1 full turn. Now, you'll also hear these measures talked about in terms of radians, in terms of pi. So how that works is the following. Remember that the formula for the circumference, or the distance around a circle, circumference is 2 times pi times radius. So you have circumference is equal to 2 times pi times the radius of a unit circle is 1. So your circumference is 2 times 1 is 2, and then pi. So a full trip around the unit circle is worth a distance of 2 pi, and then you can split it up accordingly. Halfway around is 1 pi, half of that is half pi, or pi over 2. If we go the halfway point here, we'd have pi over 4, and so forth and so on. Okay, so that will come up in the course of this lesson. You can figure out where you are on the circle, the angle, based on degrees or radians. So keep that in mind as we move forward. One of your most basic angles in drawing and in trigonometry and on the unit circle is 45 degrees. But where does this 45 degrees come from on the unit circle? Well, it comes from a 45, 45, 90 degree triangle. And that 45, 45, 90 degree triangle is half of a square. So if I make a square here, you know, if I square this off in yellow, you can see that my 45, 45, 90 triangle is half of the square. All right, so let's figure out what the distances are. What is the distance, or this leg of the right triangle? What is this distance, or this leg of the right triangle? If I know how far to go right and how far to go up, or in other words, an x distance and a y distance, that'll take me to this point on the unit circle, which I can represent that as the x coordinate and the y coordinate of this point. Well, what do we know about the unit circle? We know that every radii on here has length 1, so the radius of 1 here is also the hypotenuse of this 45, 45, 90-degree triangle. So what we can do is we can do good old Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared, and we'll put in what we don't know and what we do know. This leg here laying on the x-axis, we do not know its length at the present, so we'll call it x squared, plus this vertical leg right here, which is in the vertical or y direction, we do not know its length, so we will call it x as well, so it is x squared. And c squared, c is the hypotenuse, we do know its length, it's worth 1. So we have 1 squared. Now doing some algebra, we have 1x squared plus another x squared is 2x squared, and that equals 1 squared, which is still 1. Now divide both sides by 2. So we have x squared is equal to 1/2. Take the square root of both sides. So we have x equals the square root of 1 is still 1, and the square root of 2 is the square root of 2. Rationalizing the denominator, you'd multiply top and bottom by the square root of 2, and you end up with root 2 over 2. Now, if you put that in the calculator and express that as a decimal, that is approximately 0.707. So you can see here, this distance of root 2 over 2 is just a hair past 0.7 right here. And its height on the y-axis is also just a hair past 0.7. That's where this is coming from. So from the origin, to get to this point here, you'd have to go a distance of 0.707, which is exactly root 2 over 2 to the right. So that's the square root of 2 over 2, and then up that same amount, because again, this is coming from a square, the 45, 45, 90-degree triangle, and this is also the square root of 2 over 2. So that's literally the side lengths of a 45, 45, 90-degree triangle. You have square root of 2 over 2, which is about 0.707. This is also the square root of 2 over 2, and the hypotenuse is 1. But your position here to get to this point on the circle, it's the x value is root 2 over 2, and the y value is also root 2 over 2. So for 45 degrees, since it's half of a square and your legs are the same length, these will always be the same values because you're going just as far over as you are up to get to this point. Also from the drawing we did a moment ago, 45 degrees is its degree representation. In terms of a portion of 2 pi, this would be pi over 4. So those are synonymous. You could call this 45 degrees. Your coordinates are root 2 over 2, comma root 2 over 2, or you could say that is also the coordinate when given an angle of pi over 4. The next extremely valuable angle we're going to look at that appears on the unit circle and in drawing and in drafting and in trigonometry is 30 degrees. Now, we can look at 30 degrees, and we also can look at it in terms of a portion of 2 pi. So if you think about 30 degrees here, we have 30 degrees, and we know that we can make an even exchange. 1 pi is halfway around the circle. That's worth 180 degrees. So we can simplify here. If we're multiplying these together, we can say 30 degrees divides into itself once, and 30 degrees divides into 180 6. Okay, excuse me about that. 30 goes into 180 6 times, so you can say that 30 degrees is synonymous with pi over 6. So instead of degrees, in terms of radians, you might see pi over 6. It's the same angle, it's just a different format, kind of like Fahrenheit versus Celsius. Okay, so now since we have that out of the way, let's start working on where do the values come from at pi over 6 or 30 degrees on the unit circle. Well, let's give it a go here. All right, so first of all, when you're dealing with 30 degrees, a 30, 60, 90 degree triangle, that really comes from an equilateral triangle, something like this, okay? Where we know that on the unit circle, the hypotenuse or radius is worth 1 unit. This one would also be worth 1 unit because this is an equilateral triangle now. And then all of this would also be worth 1 unit. So if we take this 1 unit from the 60, 60, 60 equilateral triangle, that would be 60 degrees. This would be another 30 for a totality of 60. You break that in half, so then now this is half, okay? This distance, this length from here to here is not a full unit, it's half of unit because you're breaking an equilateral triangle in half. But what would this longer leg be? It's clearly less than 1 because the hypotenuse is always the largest, and it's, you know, considerably longer than half. How do we figure it out? Well, we go back to good old Pythagorean theorem. So let's check it out. If we have a squared plus b squared equals c squared, we'll call this unknown leg here, we'll call that a squared. B squared, we'll call that length our half, so that's 1/2 squared equals c squared, that's the hypotenuse, which is the unit of 1 squared. Okay, doing some algebra, we have a squared plus 1/2 squared is 1/2 times 1/2 is 1/4 equals 1 squared is still 1. Okay, get a squared by itself, minus 1/2, minus 1/4. I meant to both sides. So you have a squared, those cancel, equals a whole minus 1/4 is 3/4 or 3/4. Now we've got to take the square root to both sides. So now we have a equals the square root of 3 over the square root of 4, which is to say the square root of 3 over a whole 2. So this distance here along the x-axis is no longer unknown. It's worth exactly the square root of 3 over 2. As a decimal approximation, it's approximately 0.866. So now, if you look on my picture here, you can see that it's between 0.8 and 0.9. It looks to be a little bit more than 0.85, so 0.866 makes sense. But that decimal goes on forever. That's just an approximation. The actual value here of this length is √3 over 2. Okay? So now we know all about this 30-degree triangle. We know that this longer leg has an exact length of square root of 3 divided by 2, which is approximately 0.866. We know that this short leg is 1/2, and the hypotenuse is 1. So if you want to represent in coordinates what we're looking at here, to get to this point up here on the unit circle, you'd have to go to the right or along the x-axis a distance of square root of 3 over 2, and you'd have to go on the y-axis up 1/2. Now, I know different teachers have different gimmicks for this, but I think about this the following. For 30 degrees here, I have to go much more to the right than I have to go up. So more x than y. And I know that √3 over 2 is more than or longer than 1/2. So I know for 30 degrees, this longer one, √3 over 2 comes first, 1/2 comes second. Okay? The order will be important because next when we move on to 60 degrees, you'll see that it's just clearly flip-flopped or reversed. Okay, so the unit circle coordinate value of pi over 6 or 30 degrees is √3 over 2 for x, comma, 1/2 for y. Finally, what about if we start here at 0 degrees and we swing around, let me get my pen working, we swing around 60 degrees, which would be here. So we're going from 0 all the way around to 60 degrees. Well, since we already looked at the 30, 60, 90 degree triangle in the previous example, now the lengths flip-flop. So now the shorter leg is here, which is 1/2. The longer leg is vertical, or your y component, which is √3/2. Remember, which is about 0.866. So this is 0.5, which you can see there. This is 0.866, which you could see right about there. And the hypotenuse is always 1 because that's the 1 unit radius. So your coordinates here are for 60 degrees. It's the short leg first, which is 1/2, and the longer component, which is √3/2. So there we have it. We've gone through the coordinate values on the unit circle for 45 degrees, 30 degrees, and 60 degrees. Once you know those, everything else falls into place. And on the next segment of this video, we will put the whole unit circle together in its entirety. Oh, one last thing, 60 degrees, if you want that in terms of pi, we could just do the following. We could say, well, okay, 60 degrees. If I multiply by a conversion factor, I know that pi is equivalent to 180. And now I simplify. I say 60 degrees divides into itself once. 60 degrees divides into 183. So I have pi/3. So 60 degrees is synonymous. Its nickname is pi/3 if you're working in radians as far as the angle measure instead of degrees. So 60 degrees, pi/3, same. Okay, now we're going to put it all together. So let's put in what we know on the entire unit circle. So we know that right here, to get here, we've turned 0 degrees, which is the same as 0 pi, and we are at 1, 0. Now, if we made a full trip around the circle, we could also call that 2 pi, or 360 degrees. That would be 1 full revolution. Okay? We know that right in here, that's our 30 degrees from our 30, 60, 90 triangle. So we have 30 degrees. In terms of pi, that would be pi/6. And our position here, again, it's much further to the right than it is up. So it's the √3/2 first, which is the bigger distance, and then the 1/2 second, which is the shorter distance. Okay, next, this much in here is half of the first quadrant. Half of 90 is 45, so we're at 45 degrees. In terms of pi, that's pi/4. And that's the one that's √2/2. Okay, anything that's in terms of the halfway point of a quadrant is √2/2. So those always go together. √2/2 is a pair for the x and the y. Now, if we go here, we are at 60 degrees. Now we've gone that far around the circle. We're at 60. So remember, to get to here, it's not very far to the right, or half, and then up the bigger distance, which is √3/2. So it's half first, and then √3/2 second. Okay, that was 60 degrees, and 60 degrees is pi/3. And then finally, now we're a total of 90 degrees, or a quarter of the way around the circle. So that is 90 degrees. 90 degrees is also the same as half of pi, which would be pi/2. And from the origin, to get due north up here, you went 0 in the x component and 1 in the y component. Okay, so moving on, now we're at 90. We're going to go an additional 30 degrees. So 90 plus 30 is 120. So we're at 120 degrees. If you convert that into a portion of the 2 pi revolution, that is 2 pi over 3. And again, I think perhaps the best way to do this, is just to do a little sidebar. So I've always thought it's easier to think in terms of degrees. So if you have, okay, I have 120 degrees times, I know that pi is equivalent to 180 because that's halfway around the circle. And then I simplify. I could say, well, I know they're both divisible by 60. 60 goes into 120 twice. 60 goes into 183. So that's your 2 pi over 3. So that's how I like to do it. I mean, you can just out and out memorize it, and there's other ways, but that works really well for me. So let me erase that, and then we'll keep it moving. Okay, next we have going past 120. So we're at 120 plus another 15 degrees here. This is basically the mirroring of 45 degrees. So on the other side here, we're at 135, which is 90, plus an additional 45. So we're at 135, which is 3 pi over 4. Notice I forgot to put in the coordinates right here. Notice that 2 pi over 3 or 120, it's the mirror image or a reflection over the y-axis of here. So you still have 1/2 and root 3 over 2, but you're a negative on the x direction because you're going left and then up to get here. Left, which is negative x, and then up, which is positive y. The 135 degrees is just a mirror image of 45, so you still have root 2 over 2. But think about how to get over here. You have to go left and then up, so that's negative and then positive. Okay, so now we'll go a little bit further, another 15 degrees. So now we're here. So we have 150 degrees. Another way to think of this is if this is 180, we're 30 degrees shy of that. So 180 minus 30 is 150. So we've got that. We could also say, 150 degrees times pi over 180. Well, let's see, 30 goes into 155, 30 goes into 186. So that is 5 pi over 6. Let me see if I can erase that real quick. Okay, back to my pen. Now we have, that is the mirror image of 30. So it's root 3 over 2 and 1/2. But again, the x is negative because we're going to the left and then up. And then finally here, we're halfway around the circle now, which is 180 degrees, which is 1 pi, and that would be -1, 0. Okay, continuing on, we're at 180, plus we're adding another 30 degrees of rotation, which is 210. In terms of pi, that's 7 pi over 6. And you'll see that if you follow this here, if we follow this path here all the way straight across, we're 180 degrees or halfway around from pi over 6. So we're going to have the same coordinates, the root 3 over 2 and 1/2, but now we're in quadrant 3, which is double negative. So we still have root 3 over 2 and 1/2, but we have negative negative because we're going to get there, we're going left and down, left and down. Both of those are negative directions. Okay, there's 15 degrees of rotation in here. So 210 plus 15 is 225. In terms of pi, that would be 5 pi over 4. Again, that is a 45-degree reference angle. It's 180 plus 45 is how you get to 225. So there's your root 2 over 2, root 2 over 2. but they're both negative because you're in quadrant 3, left and down. We go another 15 degrees, so let's see, 225 and 15 is 240 degrees. That would be 4 pi over 3. And if we kind of trace this one out, we'll see we're here, and if we go straight across, that matches up with 60 degrees. So it's a half and root 3 over 2 again. So we've got 1/2 and root 3 over 2. So again, this is a 60-degree reference angle because there's 60 degrees right in here. And it's 1/2 and root 3 over 2, but they're both negative due to quadrant 3 because to get to this point right here, you had to go left and down. You add another 30 degrees, so now we are here. We're due south at 270 degrees, which is 3 pi over 2, which is 1/2, 3 pi over 2. And as far as coordinates, that would be 0, -1. Let's swing another 30 degrees. So we're 270, now we're at 300 degrees. 300 degrees is 5 pi over 3. And if you think about 300, 300 is not quite back to 360. You're short in here by 60 degrees. So this is a 60-degree reference angle. So if you look back at 60 degrees, it's 1/2 and root 3 over 2. So we've got 1/2 and root 3 over 2. But this time, to get to this point right here, you'd have to go right and then down. So your x is positive and your y is negative. So it's a negative root 3 over 2. From 300 degrees, now we add another 15. So we're at 315. 315 is 7 pi over 4. So again, we are in the middle of quadrant 4. When you're in the middle, you're a 45-degree reference angle. So 45 degrees is always coordinates of root 2 over 2, root 2 over 2. But again, the y is negative because we're below the x-axis, or to walk here from the origin, you'd have to go right and then down. From 315, if we add another 15 degrees, we'd be at 330 degrees. 330 degrees is 11 pi over 6. You can see here that this is a 30-degree angle in here. So 11 pi over 6, or 330, is a 30-degree reference angle. And 30 degrees is always root 3 over 2, 1/2. But this time, the 1/2 is negative, again, because we're in quadrant 4. You have to go right, which is positive, and then down, which is the y is negative. And then here we are back to 360 degrees, or 2 pi, which was our full cycle, and we're back at a coordinate of 1, 0. So there you have it. There is the entirety of the unit circle. I always remember, again, going back to 30 degrees, which is right in here. You have to go further to the right than you do up. So it's root 3 over 2 first, which is bigger, 1/2 second, which is smaller. The 45 degrees is the halfway point of the quadrant. So those are balanced, the root 2 over 2s. And your 60 degrees, it's less of an x move than a y move. So it's your smaller value first and your bigger one second. Hopefully this helps. If you've never learned the unit circle before, especially at the beginning where I show you that the 45 degree is half of a square, the 30-60 is half of an equilateral triangle, and the values come from Pythagorean Theorem. Hope you enjoyed this video. Thank you for supporting HansonMath.com videos, and I'll see you next time. Thanks a lot.